Okay, good evening. We've started with some of the basics of learning what a set is. Now we're going to learn some of the notation in order to deal with sets. Let's start with some of the basics of just how we label and describe our sets. So if we start with a set 1, 2, 3, 4, we, just as in the real world when we give names to lists of objects, we have a grocery list, a list of things to do today. This set can have a name, and we can arbitrarily give it a name. For right now, we'll give this set the name S, and let's give another similar set, the set of 1 and 2. Let's give this the name T. We can make a comparison between these sets. We happen to notice that all of the elements of T happen to be elements of the set S, and we give the name for this comparison subset relationship. We would say that T is a subset of S. This curved symbol represents the subset, and this bottom bar down here means that the set T could be equal to S. Most subset notation, we're familiar with looking at the sign less than or equal to. Subset can mean either a subset or the sets may be equal. Another small little bit of notation. I've commented that these numbers are elements of the set S. Another way we could phrase that is that 1 is an element of S. It is also true that 2 is an element of S. This little epsilon symbol refers to element. And let's also look at the notation for how we can define elements of a set. Let us say that we describe a set A, and this set A is going to be the set of elements, and here I'm going to use a variable, the set of elements such that X is an element of the integers. This means that we're looking at all of the elements which we can pull from the integers, so this set A is actually going to happen to equal the set of integers. But this definition is a little more flexible than our original definition for how we define the integers. Let's define another set B. B is going to be the set of all numbers in the integers but multiplied by 2. And this may be a slightly familiar set. This is a set of all even integers, which, given our previous definitions, we can see that B is a subset of A. It's fairly common that integers are going to contain all even integers. The integers are also going to contain all odd integers. So let me give a definition for what the odd integers are. Then we'll have another brief bit of notation. Let us have the set C equal 2x plus 1 such that x is an integer. And with a little bit of checking, people would be able to notice that this is indeed the set of all odd integers. And we can notice from experience that the odd integers and the even integers have no intersection. And a way in which we could refer to this is that B intersects C is a set of, well, if they have no intersection, how are we going to refer to this strange, interesting set? Well, the set of nothing is going to be what we just call the empty set. And we can either refer to it using braces, which have nothing in between them. It also will occasionally have a special symbol, a circle with a line going through it. This will be referred to as the empty set. And then this symbol here is the symbol representing intersection. If we took both the evens and the odds and we combined them together, we would expect to find all of the integers. And so this collection of everything within two sets we also have a special symbol for. We will refer to that symbol as union. So we will have B union C, and this will be the set of all integers, which right now we have defined as our set A. And this covers most of the basic notational issues which may occur, both elements, subsets, intersections, and unions. And we'll continue more later.